Welcome back to the embedded system class. Today we are going to discuss about communication interfacing. So communication interface, mainly we can communicate IO devices through two ports. So first port is serial communication port and second port is parallel communication port. In previous previous class I explained about parallel communication devices and serial communication devices. So in this in this lecture, I am going to explain about different types of serial communication protocols, why we require communication, what are the different types of serial communication ports. So mainly for long distance communication we use serial communication bus. Means in serial communication bus, in between transmitter and receiver we use a single wire. With the help of a single wire we can transmit the data, so that the circuit complexity is very less. So for long distance it is preferable. And one more important point is serial communication is very highly secure, right? So because in this serial communication we send the data serial one by one. So for most of the communication devices we use serial communication protocols. There are lot of serial communication buses are there. Communication interface required to interface an embedded system with external world. The need for communication interfaces are, why we need communication. So first one is to communicate with host system or PC or work system, right? So we need to communicate PC with my printer or printer with host system workstation, and to send or receive data to or from one embedded system to other embedded system. To send the data or to receive the data we required a communication interface, and interact with other systems for sharing the data, to share the data with other embedded systems which are connected to a network. We need a communication interface. And last point, to connect to internet so that anyone can access the embedded systems. So communication interface required for all the above points. So the different types of communication interface are given below. These are interfaces provided different functionalities and different data transmission rates. These are all example for serial communication protocols. So first one is UART and I2C, SPI, CAN, USB, I-wire interface, Ethernet, infrared. These are some of the serial communication protocols. First one is UART. So UART is universal asynchronous receiver and transmitter. Takes bytes of data and transmit the individual bus in a sequential fashion. As I earlier discussed, UART is an example for serial communication protocol. So here data is transmit sequential one by one. So it is mainly used for communication between two devices. So to communicate between two devices we use UART. UART is a asynchronous half duplex device. So there are three types of communication types. So simplex, half duplex and full duplex. Simplex is only one way communication. So if we want to send the data, we can send the data. So we cannot receive the data. So only one way communication. And coming to second one is half duplex communication. In half duplex communication, we communicate. It is a bidirectional communication device, but not at the same time. So if one device can send the data, second device just receive the data. It cannot send the data at the same time, right? So that is half duplex. So walkie-talkies are example for a half duplex communication devices. And next one is nothing but full duplex. So in full duplex communication, it is a bidirectional communication device, and we can send the data and receive the data at the same time. UART is a asynchronous half duplex communication device. So uses in projects like we can use this in debugging GSM modules, industrial machines. The baud rate of UART is standard baud rate of UART is 9600 or 1,15,200. These two are standard. In some UART they can transfer 9600 bits per second, and in some UART we can send 1,15,200 bits per second. So we all know that baud rate. What is a baud rate is how many number of bits we can transmit per second. Number of bits transfer per second is baud rate. So this is the block diagram of an embedded system. UART serial communication port. So mainly it is a two-wire communication port. So two wires means one is TX and second one is RX. Through TX we can transmit the data. Through RX we can receive the data. So this is the frame of UART. So it has four fields. First field is start bit, and second one is data. Whatever the data we send, so it is nothing but data. And third field is parity bit. So we have a parity, number of inputs, number of bits, number of ones in data, how many number of bits in ones in data. So if the number of ones in the data is even number, then parity bit is 1. If it is odd, then 0 parity bit. Next last field is nothing but stop bit. So it is stop bits are 1 or 2 bit stop bits. So mainly UART frame consists of four fields: start bit, data bits, parity bits, and stop bits. So in next unit, this is about block diagram. So next one is nothing but I2C. I2C is inter-integrated circuit. It is also a two-wire interface. Unlike UART is only communication between two devices. So whereas in I2C we can communicate more devices. So but it is a two-wire communication device. Here also we have two wires. So first wire is S data, so serial data, and second wire is S clock, serial clock. It is a two-wire synchronous half duplex communication device, right? So UART is a asynchronous half duplex communication device. I2C is a synchronous half duplex. Asynchronous means independent of clock. Synchronous means depend on clock. So this is about I2C. I2C bus was introduced by Philips. In Philips company, in their remote control, they introduced I2C bus. It is a synchronous half duplex serial communication bus protocol. I2 bus uses only two bidirectional lines. One is S data and second one is S clock. It is often called the two-wire interface. So transfer of the bus take place between a master and slave, right? So here we can communicate between more than two devices. So master will send the data, and slaves, example EEPROM, LCDs, LEDs, AD converters, D2A converters. So master is nothing but microcontroller. It will send the data to all the slave devices. Each slave has a unique address which is usually 7 bits long. So this is nothing but the I2C frame. So first field is start condition, and next field is address frame. So for each slave we will give some address. So through that address only we can communicate that device. We have different slave. Each slave has a unique 7-bit address line. So that address is stored in this field. So next one is whatever the data we want to send, we can send. This is nothing but I2C frame. So next so this is a block diagram of I2C. So communication only with the help of two bytes, S clock and S data. So microcontroller is our master and different blocks are slave. Slave 1 EEPROM, slave 2 I2C device are exam, etc, etc. So next serial communication protocol is SPI or SSI. We can call this as SSI. SCI stands for Serial Peripheral Interface, is equivalent to SSI. SSI is Serial Synchronous Interface. So it is unlike I2C. I2C is a 2-wire. So whereas SPI is a 4-wire. Here we have 4 wires. So those 4 wires are MOSI, MISO, SS and S clock. MOIS is master output, slave input, and MISO is master input, slave is acts as output device. S clock is slave select, SS is slave select, and S clock is serial clock. So it is also a synchronous full duplex. I2C is a synchronous half duplex, right? SPI is a synchronous full duplex. So here data transfer between two devices at the same time. So we have 4. It is a, so mainly we have to remember SPI is a serial peripheral device and it is a 4-wire interface. We have 4 wires, MOSI, MISO, SS and S clock, master output, serial slave input, master in, slave out, SS slave select, S clock, serial clock, right? It is a synchronous full duplex. Okay, it is a synchronous full duplex communication device. So we use this SPI in memories, sensors and displays. In displays, memories and sensors we use SPI. So this is the block diagram of SPI, serial peripheral interface. So master and slave, it is a 4-wire communication device. So in the next lecture I will explain CAN and USB. Thank you so much.